Hi everyone, we start chapter 3, probability and distributions. We discuss probability theory and random variables. So we start with the sampling distribution, so which demonstrate what the randomness is. Then after that, we study probability theory, define random variable. Then we discuss some examples of random variables. We start with a normal random variable. Then after that, the random variables associated with normal random variables. So chi-square, t, or f random variables are defined based on normal random variables. So we want to study those through computation rather than just theory. Okay, first, the random sampling. So to randomly choose numbers from a finite set, we can use the sample function. For example, that we have a set of 3 numbers, 1, 2, 3, and we want to sample from those set. For example, we want to get the 5 observations from that set. Then we can randomly choose 1, 3, 2, 3, 2, or 1, 1, 3, 1, 2. So this is a random sampling from a finite set. So this function is useful for resampling methods. Resampling methods evaluate variability of statistics, such as mean and standard deviation by simulation. For example, if we have 100 observations for some data and think about the sample mean, we can only calculate one sample mean. So we cannot see how reliable it is, but actually it is based on 100 observations, so it should have some variability. And resampling method can evaluate how reliable the sample mean is. Okay, so first, how to use sample function. So sample parenthesis 1 to 10. This is 10 numbers, 1 to 10. 5. This means 5 random numbers from 1 to 10 without replacement. So without replacement means that the same number cannot appear twice. So 6, 5, 9, 2, 8. If we do the same code again, we may have different sequence, but still, such as 1, 10, 2, 8, 5. So it doesn't have the same number within these 5 numbers. Sample 1 to 10 is a permutation of 1 to 10 because each number appears exactly once. So like 2, 6, 7, 9, 7, 8, the 4, 3, 5, 9, 10, 1. So 1 to 10 appeared once each. If we want to allow the computer to have the same number twice, we can say the sample 1 to 10 replace. So if we don't specify how many observations to take, we just take the same number of observations as this set, 1 to 10. So this is 10 random numbers from 1 to 10 with replacement. So that means the same number can appear more than once. So 10, 4, 10, 2, 6, 2, 8, 4, 5, 3. So 10 appears twice, 2 appears twice, sometimes 3 times or more. In some extreme case, we may get 10, 5, 10, 10, 10, 6, 8, 10, 10, 2, or something like that. And with replacement, without replacement, we cannot sample the more than 11 observations from 10 observations. So it returns an error. But if we specify replace is equal to true, we can take as many observations as we want. So 1 to 10, 11. So 10 appears twice, and 7 appears twice, 6 appears twice, 3 appears twice. So some numbers appears twice because we take 11 observations. So of course we can we can choose any set to sample from. So sample of C 1, 2, 4, 8, then we sample observations from this set 1, 2, 4, 8. So if we take 3 observations, then that may be 2, 1, 4, or 8, 4, 2, or 1, 8, 2. And also the character vector that we can use as a set. So sample ABC 5 replace T, then we pick up 5 letters from ABC with replacement. And also that we can change the probability. So sample AB10 replacement true, probability 0.2, 0.8, then we pick up an A with 20% probability and we pick up B with 80% probability. So probability of A is 0.2, B is 0.8. So sample, for example, this becomes this BBBA, BBBBB. Actually, we have only one A because this is probabilistic. So in the long run, we have 20% of A's on average, but if we only have 10 observations, sometimes we only have one A, or sometimes 3 A's or 4 A's. So this is the basics of the sampling function. So next time that we use this to evaluate variability of sample mean and other statistics.